All right. Hello, everybody, to part 3 of Senior Developer in 24 Hours. For this third part, we're going to continue talking about identifying and analyzing user requirements. Now, as you might remember, in the last session, we were talking about a structured approach to go from user requirements to tickets. And this approach basically implied gathering some vague user requirements, documenting those user requirements into more structured user journeys, creating epics to be able to represent the user journeys that we had defined, and then finally, from those epics, create actionable tickets. And in this session, we're going to talk about that last part, creating tickets from the epics that we have defined. All right, so how should we break up the epics into tickets? Well, the first thing is that we want tickets to be achievable in a single sprint. How long is a sprint? Well, that really depends on your team, your organization, and how you do things. Normally, we're talking about 1 to 2 weeks. If we have a ticket that is too long, that it's going to take more than a single sprint, it is always best to take it up and break it apart into multiple tickets so that we have smaller chunks of work that will make it easier for us to identify and quantify the level of effort, and to make it easier to prioritize, and also to make it easier to remove any roadblocks that a particular ticket might cause to other tickets that other developers would be working on. So always keep in mind that we want these chunks of work to be smaller, no bigger than a single sprint. We also want them to have some concrete functionality that we can test. What does this mean? We want these tickets to stand on its own so that we can see whether it's working or not working. Because at the end of the day, we want every ticket to have a completion criteria, something that defines, hey, we have achieved the goals of what we had in mind for this particular ticket. And this completion criteria is normally going to come from the users, or it's going to come from the business analyst or the subject matter experts. But we also want to have this completion criteria. And the completion criteria also plays into the definition of done. If you're working in an agile environment, the definition of done is something that normally the team agrees upon. So, that can include not only writing the code, but also writing some unit tests, getting the code merged, getting the code tested by QA if you have a QA department, things like that. So we want the ticket to take all of those things into account. We also want to make sure that we clarify the tickets with the users. We want to verify the correctness of the tickets. As we're going through the process, where we start with user requirements, and from user requirements we move into user journeys, into epics, into tickets, things, could get out of sync. We could have miscommunication between one step and another step. So as we're reaching this last stage where we create the actual work items that we're going to start handing out and working on to achieve the user requirements that we started with, we want to verify that our tickets are correct and that they really represent what the user wants. And we do this. If we cannot talk with the users directly, we might be able to talk with the business analyst, with the subject matter experts, with the people that are helping us gather these requirements that we are then putting into tickets. At this stage, it is also very important to start thinking about edge cases. We want to consider what happens at the boundaries of what we're trying to do. For example, if we are processing some kind of um, records, what happens if we get 0 records, what happens if we get 1 record, what happens if we get more than the maximum number of records that we are supposed to accept, all of those things. We want to have some clarity on how we should handle unusual input. And from a team perspective or from an organizational perspective, you might already have functionality to handle unusual input, to handle error reporting, things like that. But we still want to have an understanding of what is considered invalid or unusual input, how we should handle it, things like that. And we're going to talk a lot about this in the security part, because security plays a big part in handling input. We want to make sure that we're sanitizing our input. We also want to make sure that we're sanitizing our output. But all of those things, we want to make sure that we're in sync with our users, with our stakeholders, to make sure that we are going to do something that is actually going to fulfill the requirements that they have. We want to understand how we can handle these error conditions. What are the error conditions, and what should be the expected output when we are not following the happy path? When we are talking about user journeys, normally we focus on the happy path, but we also, at least at some point, have to worry about error conditions. What happens when things go wrong? How should our application fail when we encounter undesirable situations? And ideally, we would be able to gather and identify specific examples of test data that we can use within our automated testing to be able to ensure that our application is working to the spec that has been provided to us. And sometimes the business analyst will already provide this data to us. Sometimes we'll have to go and we'll have to gather this data, work with the business analyst, with the subject matter expert, to be able to get it into a format that first is properly understood by the SMEs. We want to make sure that when we gather this test data that we're going to use to automate our testing, that the SME can understand it to fully grasp what we're testing, to for this person to go and say, hey, you know what, this looks great, but we're missing this edge case, or we're missing this particular case, which is relevant based on the business logic that we're building, things like that. So we want it to be understood by them. Of course, we want it to be understood by the developers. Developers might not necessarily become subject matter experts, but at least they need to have some grasp of the business logic of the domain that they're working on. It is a fact of life. So, test data has to be understandable by the developers, and ideally, we'll get test data that we can put into a format that we can then feed into our automated test. And we're going to go into a little bit more detail when we go into things like testing, in particular, if we're using behavior-driven development, things like that, tooling that will allow us to develop a domain-specific language that we can use to represent test data that we're going to feed into our application. We can get to the point where the developers can understand a set of data, the subject matter experts can understand the same set of data, and this is the data that we feed into our testing, into our automated testing, to verify the functionality of our application. By doing all of these things, we can reduce the effort of QA significantly. We can use this shared language to address any concerns. If we find any bugs, we can also use the same mechanism to create test cases for those errors so that when we fix them, we avoid regressions, things like that. So if at all possible, whenever we're dealing with tickets that have significant amounts of business logic. We want to gather test data from the subject matter experts, and we want to gather them in a format that we can use in a automated way, ideally, by our tests. Okay, our tickets also should have enough information for us to be able to prioritize the tickets. For example, we want to know what can we accomplish the soonest. Because the soonest we can accomplish something, the soonest we can demo the functionality, and most importantly, the sooner we can get feedback. We always want to get feedback as soon as possible, because if we have to make changes, making those changes early on is a lot cheaper, is a lot easier, is a lot faster than if we wait a long time. So we want to avoid the case where we're building something for 3 months and then we show it to the user and say, hey, this is what we built. Is this what we wanted? Because if the answer is no, then we're going to have to figure out how we have to retrofit 3 months of work. On the other hand, if we can make a demo after each sprint, every week, every 2 weeks, we're going to get quicker feedback. And if we have to change things, because there's always something to change, we are going to have to do a lot less rework. So we want to prioritize the tickets to be able to get that feedback as soon as possible. But of course, it is never that easy. Normally, we're going to have to coordinate with other teams to be able to get things done. In this day and age, if we're working for any mid-size or large organization, we're going to have multiple teams where there is overlapping functionality that has to be completed for the different teams to move forward. So, whenever we run into an issue where we depend on functionality that is not yet complete, we're going to have to find a way to work around that. And again, we're going to talk a lot more in detail about how we can stay productive even when we have these kinds of roadblocks, and some of the techniques that we can use to ensure that our team is moving forward with these things in mind. Now, one of the things is, what are the dependencies? Make sure that we have the dependencies listed in our tickets, and then we use those things to move forward. Let's keep in mind that whenever we're creating tickets, we're trying to tell a story. As a user, I want to be able to take some set of steps so that I can achieve a particular objective. If this seems familiar, well, it is basically the same 3 basic elements of the user journey. Who is the user? What are they trying to achieve? And what are the steps that they need to take to be able to achieve this objective? So as part of the ticket, you're going to have a lot more data, but we always want to be able to tell this story. I am a user. I want to take a certain set of steps so that I can achieve a particular goal. So we're basically going full circle. We start with some vague user requirements. We consolidate that into something a little bit more structured, which are the user journeys. We start breaking those apart to epics, and then we break those epics further down into individual tickets. But again, just like we're getting a story from the user requirements, each ticket should also tell its own story, although it's going to be a much more granular, bite-sized story. And these little stories are what are going to help us, drive the development forward. All right. So, what are some of the pieces of data that we want to have in an actual ticket? So, for example, if we go back to the field technician that we've been talking about, where they are on site, they're working with a customer, and they want to create a work order for a particular customer. We could have a ticket that looks like this. In here, we're focusing on that little piece of the journey where the technician is searching for a customer because they want to create a work order for this customer. So again, we've broken down the process. We've broken down the user requirements to something really bite-sized. That is, we need to create an endpoint for searching for customers. As part of the whole user journey, this is one of the little interactions that are going to help us compose the user journey at large. So we want to create an endpoint. That endpoint is going to live at /customers. This endpoint is going to be accessible by field technicians. So here we have who they are. It is going to take an arbitrary string, this endpoint, and in here, we're not worried about the user interface. We're just creating the endpoint. We've decomposed the user journey into very granular tickets. So this one is just the endpoint that some UI is going to hit. And this endpoint is going to take an arbitrary string. It's going to match that string against all of the fields in the customer records that we have in some database. It's going to return the list of matching records. So in here, we have who the user is. We have the steps that the user is taking. Basically, they're sending a string. It's going to be an arbitrary string. And we also have what they're trying to accomplish. They're trying to get a list of all of the matching records based on the string that they sent. And then we go into some of the implementation details. What happens when we run into some of the edge cases? For example, if we have no matches, we're going to return an empty set. We're not going to return an error. We are going to return an empty set. So here we start getting to some of the more nuanced details that we have to take care to be able to implement this. We're also going to, for example, document the data format that the UI is going to expect whenever they hit this endpoint. And this is a fairly simple example because we have no business logic per se. We're basically just searching things. So we don't have any significant test data here, but if we were dealing with more specific business logic that will result in complex algorithms, we would like to have some test data here. And again, we're going to talk about examples. We're going to talk about the tools that we can use to write all of these tests in subsequent videos. But this is how we start creating tickets that are actionable, that are easier for us to shuffle around in terms of priority, and that they have the right scope so that we can, first, we can show progress. If we create this endpoint, we can demo the endpoint. Sure, we might not have the UI first, but at least we can show the endpoint working on its own. And we can also deal with dependencies if need be. For example, if the data store is not there yet, then we can figure out how we can work around that and things like that. But this is a self-contained piece of functionality that will be a good fit for a single ticket. Obviously, hey, there's other things like, hey, how are we going to populate the data store that we're going to be querying? Well, that definitely sounds like a different ticket. How is the UI going to look like? Well, that's a different ticket. But in here, at the end of the day, we've gone from user requirements to user journeys to epics to tickets that look something like this. All right. And with that said, let's talk about another way in which we are going to create tickets. And this is, unfortunately, when we run into bugs, we're going to also create tickets. Now, this is a different type of ticket because we are not adding new functionality, we are fixing functionality that is already there. But just like it is important for us to create some high quality tickets for new functionality, for new functional requirements, it is important for us to create high quality bug reports. All right. So the first thing is that a high quality bug report should enable the developer to reproduce the issue. That is critical. If the bug report does not give us the necessary information to reproduce the issue, it is not going to be a very useful ticket or a very useful bug report. Second, it should help us triage the bug. How severe is the bug? What is the impact of the bug? How many users are impacted? Is it every user that is impacted, or is it only a tiny subset? Again, how severe is it? Is it just something annoying? Is it something that could be potentially dangerous? Is it something that could be potentially destructive? Is it going to destruct data? Is it going to cause, you could have bugs that could have real world implications where people could actually get hurt. So we want to get enough information to be able to triage the bug. So we need to identify exactly what data we need. And the first thing is, well, we obviously want to have a title and a summary. And the title and the summary must be concise and descriptive. We want to have the expected versus the actual result. What was the user expecting, but what did they actually get? The steps to reproduce. What did we actually do to get to that actual result? And here is where we want to make it easier for the user to create good bug reports, because if we don't get the right steps, if we cannot reproduce the bug, then it is not going to be very helpful to any of the parties involved. Okay, we also want to know in which environment did it happen. Is this something that happened in the production environment? Is this something that happened in one of the testing environments? Reference information. Anything extra that will help us as developers, anything else that would help QA people that potentially would have to test a fix for this issue. So for example, that could include things like logs, screenshots, URLs, things like that. Any attachments that could help us reproduce the issue and understand things like the severity, the impact, and the priority of this bug. Again, how many users were affected? How severe are the effects of this bug? All of those things. And the quality of the bugs that we create depend a lot on the quality of the questions that we ask. So whenever we are having users or people from the QA team or business analyst or whomever creating those bug reports, we want to make sure that we ask the right questions, and we want to make sure that we ask them in a way in which we make it easier for them. Okay, so for example, we can create templates that the user can fill in to make sure that they fill in all of the pieces of data that we want. A template will guide the user a lot better than just a free form text box where they can enter whatever data they can. If they have a template, it is going to be a lot easier for them to actually go step by step and give us all of the information that we want. Okay, we can also have built-in bug report functionality within our applications. There are things that we have to take into consideration. For example, do we have consent from the users to gather the data that we need to be able to file the report? Are we going to be in a position where we can actually submit the bug? All of those things. But if we build this directly into the application, we can get a lot of the internal data that hopefully will get us to a place where we can reproduce the issue. If we are talking about internal applications, we can potentially expose a transaction identifier, and then we can have people submit that transaction identifier so that we can correlate a bug report with information about that transaction, mainly things like logs, for example, especially if we're doing things like distributed logging, where we have a transaction ID that follows a particular user request across multiple systems. This transaction ID could get us a lot of useful information. And yes, and we're going to be talking a lot more about distributed transactions and distributed transaction logging in some of the future videos. But you know, part of this is we ask the user to get us some information, but we also build our systems in a way in which we have enough observability to be able to get metrics, get logs in the right format, so that we get all of the data that we need to be able to quickly address any issues. Nonetheless, we're always going to run into problems with bug reports. You know, we can have issues with vague wording. We could have, for example, lack of steps to reproduce the issue. You know, we get like, hey, I got an error. Okay, great. What did you do to get that error? For example, we could get no expected outcome. Like, hey, this didn't work as I expected. Well, what were you expecting? We could get ambiguous actual outcomes. Like, hey, I don't know if I got what I expected. Like, well, what did you get? Like, well, I wasn't sure. I didn't look right, but I'm not exactly sure what I got. So maybe we don't get the actual outcome in a format in which we can digest it. So that is one of the problems that we sometimes run into when we're shuffling bug reports. We might be missing attachments. We might be missing log files, things like that that we expect the user to provide for us to troubleshoot this particular bug. We can also get misleading information. For example, the user might tell us that they're using a different version than the one that they're actually using, which could lead us down the wrong path. Now, with that said, when we run into problems with bug reports, first thing is that we always have to keep in mind that the ultimate goal is to have a better application, a better piece of software. And that is a shared interest across users, product management, developers, and so on. So we want to be objective and fair. You know, always keep in mind that ultimate objective, which is have a better piece of software. Having said that, when we get bug reports that are not workable, sometimes we have to send them back. If we have a direct relationship with the user, if it's an internal user, things like that, we can go and we can work side by side with the user to improve the bug. But sometimes, hey, we cannot fix them. We're going to have to close them. But again, we're trying to keep things in mind that what we're trying to do is improve things for the benefit of future users, for having better versions in the future. Now, with that said, we've already talked about some of the things that we do to create new tickets. Now we are going to think about the next video in which we're going to start bootstrapping a project from scratch. setting up the basic architecture, and talking about cross-cutting concerns that we can use. And as usual, thanks for watching. Don't forget to subscribe. You can follow me on Twitter, you can follow me on Mastodon, or you can hit me up on my webpage. Thank you.